What is up? Daniel here with the Virtual Robotics Studio, and we're back basically to finish the robot up mechanically and electrically. So we have our hopper and fuel mechanism attached. Obviously, we have to wire those motors still. We got our radio, robot signal light, batteries, a couple other minor things to take care of. We're going to polish all of that stuff off in this video, but before we start, another special thanks to Argosy. First, Cross the Road Electronics, West Coast Products, Aramco, and Team 302, Lake Orion High School, for hosting our studio. All right, we can kind of approach this in whatever order we want here. I guess we've got our motors. Let's go ahead and get those taken care of first. So somehow this motor has to get down to, we had those wires kind of buried in here that this robot is much easier to reach inside of than regular Kitbot. We got all that extra space. All right, we have our wires here. From our SparkMax. And we got to get those red and black wires at some point in some way to connect to these red and black wires. Looks like they are, if we go exactly straight down, they might work. We don't want to run the wires on the inside of our hopper, just because that's where balls and things are going to go. So if we run back maybe along the churro, and then come to the outside, like if we put a hole in the plastic piece here, we can come to the outside and then start going down. And then let's see if the wires actually reach each other or if we have to do an extension in between. So let's grab a drill. And my guess is to fit those two wires through, we're going to be looking at something like a, I'm going to start with a 3/8 drill bit. Hopefully that gives me enough room. And it really doesn't matter where we drill this hole. My thought is basically, I don't want to drill into the metal, though, because then the wires will go through the metal hole. That's sharper. That could damage the wires. But also, the metal piece is harder to replace than the plastic one. Also, the metal piece, if I drill through it, I'm going to drop metal shavings all over the electronics that are already inside the robot. So just keep in mind, if you ever have to drill through metal, aluminum or whatever over top of the robot, you got to do your best to cover up all of your electronics before you do anything like that. But with plastic, it's okay. It's not conductive, so that'll be fine. So what I'm thinking is if I go along this churro, I could sort of dip down and put a hole somewhere here. So we have the hole for the zip tie that's holding it on. And essentially, I just want to go near that, but not close enough that it's going to cause a problem, and not close enough to the edge that it's going to cause a problem. So there's like a big bolt holding this churro in. I'm kind of lined up with that and just moving over until it feels like I'm far enough away from the other hole. Say maybe 3/4 of an inch. And just pop that through. That looks reasonable. Let me just quickly check, can I get 2 wires through a 3/8 hole? That's about the perfect size. I'm going to deburr that hole, though, before we move on. Even though it's plastic, getting rid of sharp edges seems like always a good thing to do. Get the inside as well. All right. And now we got some plastic shavings in the robot, but again, that's fine, especially compared to aluminum. All right, so if these wires are going to route out this hole and basically drop straight down here, you know what? I think we're going to be able to connect directly. That looks good to me. So let's start routing these, though, and see if we lose too much space when we add some zip ties and anchors, because I don't want these wires to just be flopping around on the outside. So first, I'm going to come back across the churro here, and I'm going to get a zip tie around the churro. And I'm going to do my best to keep that zip tie end basically towards the motor. Right, so it's sort of tucked into this pocket here where things aren't going to hit it anyway. Certainly not under normal operating procedures for the game pieces. And then we're basically going to drop, I think we're going to drop straight down from where I put my hole. So if you have any zip tie anchors left, that's what I'm going to use. If you don't have zip tie anchors, of course, you could do a couple little holes and do a tiny zip tie, going through the plastic and back through. That will put more stuff on the inside of the hopper, so that's maybe not perfectly ideal. But you can always get more zip tie anchors pretty much anywhere. Hardware stores have them. But we just want to control this, make sure it's not going to get stuck anywhere. So I'm going to put one about halfway down. And let's throw a zip tie through there. OK. I'm starting to think this bag of zip ties might not have been the highest quality ones. Looks good. And then while we still have a little bit of space, I think I'm going to go ahead and try to get these connected to the wires. So coming out of that Spark Max, we have a red wire, a black wire, and a white wire. The white wire, again, we don't need that. That's only if we're doing a brushless motor. So if you modify these motors, if you swap these motors out for a more powerful brushless motor, then you'll need to also route that wire. But for us, it's just these two. And this will be a little tricky, but I think I have enough access. We need to strip the ends of these wires so we can attach our lever nuts, our Wagos. So there's one. There's the other one. And I think the other side is even easier to connect. So if you can get this one done, you're in great shape. And then grab yourself a couple of lever nuts. And I'll go ahead and add. I'm going to do the inside ones first because they're harder to get to. I guess technically the outside ones are going to end up in the same place when we connect them. So maybe, I don't know. I'm still doing the inside ones first. All right. Uh-oh. I had a wire caught on the outside. So I'll give it a little bit of a twist and try again. Looks good. All right, and then the other side, get the black wire into the and tug. Not going anywhere. Let's do the same for the red one. And tug. That looks good. All right, now we've got to kind of deal with this excess amount of wire that we have here. So the first thing is I can kind of tuck this under some of the other wires that are there. But I'm going to have about this much left on the outside. So if I came straight down, that's like just a little bit more of a loop than I really want. So instead, what I'm going to try to do is take that loop up on the outside here. So I think if I add one more zip tie anchor right about there, I'll have this little bit of a loop and we'll be good. Now, you could cut the motor wires down, and that would be good. That would give you, obviously, you can go straight down and then anchor it straight down instead. The reason why I'm not doing that is, again, just because these wires are attached to the motor, they're really hard to replace. Essentially, you can't replace them. So if you cut them down in the future, if you need the wires to be longer, you're going to have to add an extra connector. So for this, where it's something like this, where I might reuse the motor again next year, again, I don't know what next year's game or kitbot is going to hold, but I do know that we've been using these sim motors for a while now. And so there's like a decent shot that we're going to have the same sim motors again in the future. Now, what do I want to do with the wire on the inside? So I usually like to find a way to keep these connectors from moving around. And I'm wondering if if we come up against the bottom, maybe down here where it's hard to see, maybe over here. Because I think, well, you know, it's not terrible if we leave them kind of tucked under the radio module like that. I think that's OK for now. We'll leave that. If you find out that these connectors are moving around too much on you, you could try to pull them down a little bit lower and zip tie them to stuff that's there. Or you could pop them out from where we were hiding it and bring them up to the top and add another anchor and zip tie them to the bottom of the hopper. All right, but I think mine are like tucked in behind the radio module. I think that's probably OK. All right, next, let's go to the other side. And we can do the same motor on the other side here. snip off some zip tie ends. All right, I'm gonna turn the robot so I can get to it. Okay. So now we've got our speed controller up here in the front. So for this one, we're definitely either going to be routing through the area and up, or we can maybe just come up. We can maybe piggyback off the module here and then jump up to the side and run. These wires are probably not going to reach, but let's go ahead and do the same hole. I think we need the same hole in order to be able to get these wires to the outside and start routing them for real. All right, so once again, I'm kind of going to find the bolt here that's holding the churro in, move over just a little bit, make sure it's going to not hit the edge of the plastic or run into the other hole. Seems all right. And I don't know if I mentioned this before, but I'm just a little worried. Going over the top like this is probably okay, but it feels like things could land on that. And I don't really want the wires to get hit. Certainly not on the metal, but even on the plastic, it scares me a little bit. So I like having this little access hole where the wires are a little bit more protected. And let's clean that hole up. And the inside. All right, and then I think we do the same thing. We'll start with, feed the wires through. And then I think we start with one zip tie right here on the churro to kind of do some stress relief, anchor it in place. And again, I'm trying to keep the wires towards the inside as much as possible for as long as possible, just to not interfere with any of our ball storage. All right, now, is there any chance that these connect together? The answer is kind of. They do connect together, but everything is going to have to get pulled a little bit tight. So you have a couple options here. One of them is, you could adjust the position of the Spark Max if you want to get a little closer. I do kind of like where we had all the space for our other wiring, though. So I guess in this case, I'm going to be OK with extending these wires out a little bit. So let's get some of, you can use, if you have that 10 gauge wire that's flexible and nice, you can use that. Otherwise, I believe there was some of this 12 gauge in the kit of parts. And the wire coming out of the sim motors is 12 gauge, so it's fine to sort of match the same size. And I'm going to get, we don't need that much excess. I mean, I don't know how we're routing it, but I'm going to get about 18 inches of wire here, just so I have plenty. And then I don't want to work with my whole spool. If you have like a piece that's about that long but a little longer, it's fine. You could probably leave it. And then we're going to need to strip 2 of those wires down. Wrong one. There we go. All right, and we're going to do 2 of our Wagos here. All those wire strands in. There's one fighting me. All right, there it went. All right, and then on our speed controller that's coming out here, we have the red and the black. So we'll go ahead and strip those as well and put those on the other side of our Wagos. All right, tug. Wait a minute. Something's not right. The colors need to match. Actually, in this case, technically, they don't need to match. We're going to a brushed motor. So if we send the opposite colored wires up there, it's just going to flip the direction that the motor spins. That's going to make programming perhaps a little bit more confusing, and also it's just better to do it this way and fix it in the program. All right, so if we go up like this way, we can maybe get our connector onto that same post that we did our other stuff to. Then we could jump up to here and maybe have a second connector. Like, where do we want to route this? Like this, maybe? Yeah, man, we just needed a little bit more space. All right, let's go ahead and I'm going to do a zip tie anchor on the connectors down here at where we did the post, where we did our other wires running up and down there. So I'm going to just bring the connectors over to that location and get them zip tied in. It feels like a good safe spot to keep our connectors from moving around. Good. All right, and now we want to have just enough room up here for our next set of connectors. Oh, they slipped out. I didn't tighten it enough. Is it worth trying to get them back into the mostly tightened zip tie or just get a new one? All right, I'm going to get a new one. All right, same plan. Except a little tighter. All right, that's good. Okay, so now these ones we can come down, and these ones we can come up. It looks like now we're going to be a little bit too long, so maybe I'll route these. Maybe we route them this way, because then that's going to give us a spot right here to do our connector, and we can flip the order that these go so they match the way that these ones are going to go. So I think we'll do something like that. So that looks like I want to cut it right about here, just enough so that the connectors are going to be up on the side plastic where we can anchor them in place. So I went way too far on my extra there. I think I was sort of contemplating whether it was worth it to route them as we strip 2 more wire ends. Contemplating it was worth it to route them like on the inside and come up really close. But then I saw the gear is here, and I don't really want to run this right next to the gear, is what changed my mind. All right, let's get our Wago connectors on this side. Pull on it. And pull on it. Looks good. All right, and then we might as well connect the other side. If you ever have these wires, I think these wires were pre-stripped. If not, go ahead and strip them. But if you ever have these wires messed up so much that it feels like you can't get them nicely into the Wago connector, just clip right at the end and then re-strip it. That's always a fine solution. All right, let's connect the red ones together and then the black ones together. Nice. And then looking for one more, probably more than one, probably 2 or 3 zip tie anchors here. But we want one right where our connectors are going to end up. So right about there. Seems good. All right, and we want them to go this direction. Okay, and then we can sort of bring this up until those wires are, relatively taut and flat along the path that we're going to take here. So it looks like right around here is one. Well, that was just, well, all right. That was slightly too far away, but I think it's going to work. The wires are just not going to sit flat on top of that one. it's already stuck on there pretty good, so I will go ahead and not waste this connector. So they're going to hang off to the side instead of being right on top. And that's okay. All right, and then I want another one somewhere around, probably somewhere around here. And tighten that one on. All right, that looks good. Trim our zip tie ends. All right, now our two motors are connected. Next up, let's take a look at our radio and where we might want to route the radio. All right, so that is in the Vivid hosting box labeled Robot Radio. And on this, I believe, well, there are some dip switches on the back. And I believe if you are practicing at home and you're going to be using this on 2.4 gigahertz mode, you got to flip one of those switches. So you might want to skip ahead to our software setup video or check the documentation to know which switch to flip. On the other hand, we're just zip tying it on. So when we have to cut the zip ties off later and re-zip tie it, that's not a big deal. Now on this, there's a few things to look at. So there's a side with two Ethernet ports. One's labeled DS and one is labeled AUX1. DS is going to be for our driver station if we're going to plug in directly. AUX1 is for anything else that we need to plug in. Now on the other side, we have a 12-volt port that we're not going to need to use. And then we have a Rio port and an AUX2. AUX2, again, whatever else you need to plug in there. Maybe you have cameras or something like that. Or other devices. The Rio, though, is the port that needs to then go down. That's where power is going to come in on our power over Ethernet, and that's also what is going to plug into the Robo Rio to get its signal. Now, when you're mounting this, there is a location on this robot to mount it directly. But if you don't want to mount it there, you do have to make sure you're mounting this against metal. It needs to be against a piece of metal so that the metal can sort of act as a heat sink for it. Otherwise, especially if you're practicing in 2.4 gigahertz mode, it'll heat up a little bit, and that might cause you some problems. So there are some other places on the robot, like inside on our frames here, where you could maybe find a place to attach it instead. But this was designed to attach over here in between the two holes. Now, those holes exist on the other side of the robot as well. And it looks like it would be more convenient for us to mount it on that side. You spin the robot around so we can see and talk about the same thing. So we have it on this side as well. The problem, I think, though, is if we put it on this side, there's room to mount it, but the wire that would be coming out of the bottom is going to be like right up on this belt, and that's not good for us. Okay, so the radio looks like it is going to have to go on the other side, which is the original side. That is the side it was supposed to go on. We'll see if our power over Ethernet is going to have to maybe face the other direction on the inside of the robot. So we'll flip ourselves back around here. Try not to drop off the edge of the table. All right, and once again, we're going to pass zip ties from the outside and then back out. And I can kind of prep both of these. Okay, and then make sure the Rio port is facing down. So the side with the extra power and the Rio port are facing down. The DS port should be facing up. And there are these little notches on the side. That is actually where you want your zip tie to run, because the zip tie will lock in to those notches and hold it in place. Right, so the zip tie is really good at making it so it can't come off the plate, but then those notches stop it from sliding up and down too far. All right, that looks good. Now, for that, there was an Ethernet cable. I believe it was this blue one that came in the kit of parts. Obviously, you can use any Ethernet cable you want. And this needs to plug in on the bottom to the Rio port. So the Rio port is the one that is closer to the power, the little power port. Again, we don't need to use the power port because we are using the power over Ethernet injector. Now, we're going to need to route this wire, find our way underneath here, and then, actually, this looks perfect. If we come underneath, it's going to plug into, if you remember, we had this radio, power over Ethernet, little dongle here. Let's turn a little more. There we go. So we had this thing, which has an Ethernet port. Remember, we extended 2 power wires in to plug that in. The Ethernet is then plugged into our RoboRio. So that is where this needs to go. So I can go ahead and plug that in there. And then we get to choose where we want to deal with. I get to plug that in there. There we go. It should click. OK, now we have some excess wire. Obviously, we get to choose where we want that to end up. For me, I don't think it's bad if we have the excess here. And maybe if we need to do a loop, we can do a loop on this end and attach it. Because underneath the basket is nice. Nothing is going to hit there. It's out of the way. And that's clean. That's even better than doing it on the side. But let's go ahead and rotate back over. And we'll start. That means we'll start routing from the radio. And we'll use all of the excess on the inside of the robot once we get there. So just like we were doing with the power wires, it's totally fine to drill holes if you want. Instead, you can use the zip tie anchors. All of that is good. Now, I'm not 100% sure where we want this to go, but I know there's a lot of moving parts here, right? So this belt here moves. This gear moves. I got some plastic on that. So if you are spinning this gear and you feel it locking up in some places, check to make sure you don't have any plastic bits stuck in there. That seems kind of OK. All right. So we need to not hit those things. So we want to have some anchor somewhere, right, like pretty quickly to pull it over and make sure there's no slack that's going to get us into trouble with any of the moving parts of this robot. So I think somewhere right around that circle, leaving a little bit of space above that big circle cutout, seems like a good first place to go. So we'll do that, and then we'll see what's next. All right. Now, we can go down again on the metal, or we can drop down to our channel here and run on the channel. I think I'm going to stick to the metal. I guess they're both metal, technically. They're both aluminum. So I'm going to stick to our fuel mechanism plate, because I think if I go down here, I'm still just going to jump over. I see almost no difference. So choose whatever you want. We're still going to go underneath the hopper when all is said and done. So it's kind of up to you. I'm going to do one down here, sort of right where we're going to start making that transition to the hopper. This might have been a good one to pre-place the zip tie as well. I think if I bend the end a little bit when I push it through, that'll help it move around. And if you're running out of zip tie anchors, you could go to the bottom and use the hole if you have the full channel there. All right, then I think I want another one pretty quickly on the other side of this corner, just to make sure that we're not going to go down and rub into the stuff that's there. And I kind of like the idea, like we can pull it underneath the metal section, but I kind of like the idea of leaving the radius a little bit bigger so that it's a nice smoother curve. It's got more room to turn around. So I'm going to do it right on the plastic, close to that metal part of the ramp. But anywhere in this ballpark is going to be just fine for you. So somewhere right around there. Okay, I forgot to cut the zip tie earlier. Okay, moving right along. It's going to basically just run straight across. And, okay, so if I pull this straight across here, ooh, it's shiny. All right, if I pull this straight across, it's going to leave us with about that much slack. Actually, I think that's about perfect. Because Because if I try to make this too tight, it's going to be hard to plug this in and unplug it when necessary. So I think we just go straight across and we see how that much slack looks. I'm going to then basically do a zip tie all the way at the other end here and see if 2 zip ties is enough. It is kind of like in a protected spot. You might end up wanting to put a 3rd zip tie in the middle if it feels like that wire is being a little too unruly. All right, so I'll just kind of pull it tight and then tighten that zip tie down. Yeah, I would add another one in the middle. Feels a little too far of a span for me. But I definitely think I am into the neighborhood where you'll need more zip tie anchors. I think I've used more than came in the kit of parts now. All right, this one is good. Yeah, that's less scary to me. Again, basically the idea is just control the wires, don't let them do anything crazy. All right, if we spin this back around a little bit, we can look at where we have to plug in here. And so if I try to basically unplug this and then plug it back in, how is that going to go for me? So if I unplug it, I have this much wire to plug it back in. And now what if I pretend like I only had this much wire? Yeah, this is just about perfect. It feels like that loop is a little bit big, but to actually be able to manipulate it to plug it in and unplug it, that does not feel bad at all. You could, if you wanted to control this, once it's plugged in, and you know you're not going to take it out for a bit, you could maybe add one more anchor right onto the Robo Rio here to stop it from moving. But I don't really want to pull it up any higher like that. I kind of like the way it's sitting for me. All right, so that is the radio done. Now we have the robot signal light. And the robot signal light, we've got a few choices. So that is this thing. It fits in the holes either here on this panel or on the other side. We have the same hole because obviously these panels are the same. Now I think in the non-Swerve Kitbot instructions, we put it on this side, and that worked out for us. The one negative to putting it on this side is it's a little hard to access the DS port that's over here. But the wire fit nicely to where the Robo Rio was on the other robot. I'm wondering if we can flip it around and put it on this side and be able to route it. So there's no specific rule for where it goes. Sorry. And this is basically just threaded. So let me undo this. Kind of did it out of habit as I was holding it. So, all right, on this, there is a plug on the bottom. It's got those flathead screws, kind of like we did in the last video for the Robo Rio. And then there are ports that we can plug in labeled LA, N, and LB. N is for basically our ground. And then that plug, if you just grab it, you can just unplug it. That'll just pop out. Then there's a little plastic nut on here that's probably starting screwed way down, but just unscrew that nut. Or hold the nut and unscrew the light, either way. Now we can take this and we can fit it through the hole. So now it'll slide through the hole. And then we can screw the nut back on the inside. Or again, hold the nut and spin the light, your choice, whichever way you want. It does not really matter which way this ends up facing, because when we plug the wires in, the wires are going to be sticking straight out of the bottom. So they'll go straight out. So whatever we're going to have to loop to come back. But I'm thinking like, because we can go on the inside until we get to the plastic, we can maybe run through the same hole we drilled here. And then our robot signal light plugs into the Robo Rio, which is like literally right below on this side. So I think that's a little bit of a cleaner wire run, and it gives us access, a little bit better access to that DS port on the radio on the other side. But if you want to put it on this side, I think I checked, and the wire is long enough that like it's going to reach no problem from wherever you want to put it. So have at it. Now, on this connector, we've got to do a little bit of work. So first thing is there are 2 ports here, LA and LB and N. So N is easy. We're just going to ultimately strip the black wire and put that into the N port, and we're good to go. The red one is going to go into LA, but we also need one more tiny wire that goes from LA over to LB so that they're both connected to our positive voltage when we send the signal. So first thing, since I'm holding this, let's go ahead and strip these 2 wires down so that we can plug them in. And this is probably 20 gauge wire, if I had to guess. My 20 gauge spot stripped it perfectly, so I will continue believing that's the case. All right, so those are stripped. And then we're going to have to grab a little piece of, we've got the 18 gauge wire that came in the kit. I've got a little bit left over from what we were wiring earlier. So we'll need this. We need to strip 2 ends of it. You could try to get a really, really tiny piece, but one of the issues that you'll run into is, first of all, you have to be able to bend it around and come back in. So it's got to be about that long to begin with. And going much shorter than this size, it's going to be pretty hard to hold on to this to strip the wires, especially if you don't have an automatic wire stripper and you've got to like hold it and do the extra thing. So I'm looking at, I would say, about a 2-inch section of this wire is probably about the right size. You could go a little bit less if you wanted to push it, but there's nothing here, so if it sticks out a little bit more, I don't think that's a big deal. So we'll clip that. And then we've got to strip both ends of this wire. And then this one was 18 gauge. Perfect. Okay, and then we can just sort of prep it by doing our best to bend it into a little horseshoe, bend it in half. All right, now I got to go grab the flathead screwdriver so that we can screw those terminals in to hold stuff together. So the first thing I'm going to do is I'll start with this little horseshoe wire, and I'm going to put it into LA and LB and stick it all the way in there. Now, again, just like when we were doing the Robo Rio, if you've got exposed wire sticking out, then you should trim it down. This one here is like right on the edge. You can see it's just either just sticking out or just not sticking out. So I'll live with that, but if you were going any out more than that, you should trim it down a little bit. All right, and then now that that horseshoe is in, it's kind of holding itself there, which is nice. I'm going to tighten down the LB port to lock it in. So it's, again, just that screwdriver on top. Just tighten that screw down. It's going to clamp in just like we did on the Robo Rio. Perfect. And then we need to grab our wire harness. And this wire harness, by the way, I think it was in the Molex box. So what we're looking for on this wire harness is on one end, you should have a little 2-pin connector. So there's a little plastic connector, kind of like the ones we were using or we saw when we were doing our CAN wires earlier, but instead of 3 slots, it has 2. They both had 2 wires, but the other one had a 3rd slot that was empty in the middle. And then the other side is just 2 bare wires. So that's the one you're looking for. That was in one of the 2 Molex boxes. I can't remember which one. All right, now we're going to take the red wire from that connector and add that also into LA. So we've got both of those wires going into LA, and then we tighten it down. Good. And then finally, you can kind of bend this one down out of the way if you need to. We're going to get the final black wire into the middle port. And of course, you can do this in any order you want. You don't have to do it in the order I did it. I'm never sure what's the best, because like this way we have to do the middle spot last, which is the hardest. But I feel like the horseshoe sometimes is the hardest part, so getting that out of the way first is nice. All right, now this is going to plug into our light up here. And it only plugs in one way, so if you try to plug it in and it doesn't work, that's fine. I think it only plugs in one way. Now I got to test. Yes, it only plugs in one way, so if it doesn't go in, flip it over. And now we basically need to get this wire, and you can kind of bend that horseshoe think I would even pre-bend that horseshoe kind of down like this. Just because like then if anything falls in there, it's less likely to cause us a problem. That said, the robot signal light, it is by rule something you need on the robot. It can help you diagnose your robot if things are not working right on the field. But if the robot signal light were not on the robot would still function perfectly fine. So if it does get broken, this is not mission critical. Like the radio gets broken, you're not communicating with the robot, that's a problem. But if this gets broken, you just stop getting that data, stop getting that feedback. All right, so we're looking to have a little bit of slack here, but we want to come in and get an anchor pretty close by to sort of lock this down and hold it in place. So let's see if we can rotate a little bit more because we're working on the inside here for a minute. This robot just barely fits on the table. I feel like I'm always putting the wheels right on the edge. All right, so again, I want this to come in, have a little bit of slack, but be kind of close by. So somewhere around there feels like a good spot for starters. Just get our zip tie going. So, and I want the first zip tie to also get on. It's got this extra webbing, which is just extra wire, insulation wire protection. So it's nice if you can get on that, because I think you can hold on to it a little bit tighter. And then, we've got a little bit of slack here, so we're not pulling on those wires. Actually, I'll pull mine a little bit back through just to have a little more slack. That feels good. And if possible, we would like to pass this through the hole that's already there. But that is not going to work because of the zip tie that's on here. So I could clip the zip tie that's on here and maybe force it through. Seems like maybe I'm better off just drilling another hole. So I'll do that instead. So here, like right, if we run this wire straight across, feels like a hole somewhere in this neighborhood is perfect. So again, I've got the hole that's already there holding it together. I'm just going to kind of move. Do I want to go below? Yeah, I'm just going to go below that hole. Again, shift in a little bit just to make sure I have plenty of clearance to the edge of the plastic piece. And then we'll go ahead and drill through. And still toss some of those plastic shavings away. Clean that hole up. Still a 3/8 drill bit. Hopefully that's big enough for the zip tie to fit through. It just barely is. Whew. I got scared for a second. All right, so that's going to get through to the outside now. I think I want to do, this might be me getting a little overkill again, getting a little too worried about stuff, but I'm going to do one more zip tie right before it goes through, or zip tie anchor right before it goes through that hole. All right, and then if we look all the way down, we're kind of back now onto the other side here, but if we look all the way down into our RoboRio, basically if you're reading it right side up, we got the words RoboRio here. If you go down to the bottom, on one side we actually have our reset and user buttons. On the other side, there's a section labeled RSL. That stands for Robot Signal Light, which is indeed what we are wiring now. Next to it, you can see two little symbols or writings. One of them is, I believe, the letter S, and that is pointing towards the top hole. And the bottom looks like, I feel like that's like an umbrella. Maybe it's a spinning top. That is the symbol for ground. So the pin towards the outside edge of the RoboRio is going to be for the black wire. And the top one, the S, the signal line, is going to be for the red wire. That's where we send the power. So you can plug that in. It's just those two pins. Plug right on, or right into the connector. Okay, now we've got to deal with all of this excess wire. And again, this is one that I reuse. I think this actual one that I have right here, I reused in a previous year. So, or from a previous year. I think this might have been my wire from last year. So I kind of like leaving these whole. If you want to cut it, you can cut, right? So obviously all this could come down to here. We could probably cut it, about here. If you do that, right, you cut it, and just like the end that's already there, you would basically re-zip tie the zip tie on, but don't cut the end with the connector. If you're going to cut it, plug the connector in, route it up this way, and cut the bare wire end, because then you don't have to reattach the connector, right? So that would be on the LED side, on the robot signal light side. All right, but what I'm going to do is I'm going to find, like, what path do I want to take to get this up to the top here, you know? And I think in this case, again, I don't love jumping directly up through the air, but, you know, it seems like that might be the answer here. So yeah, I'm going to do one zip tie anchor right on top of my RoboRio. And it looks like I'm going to be, for where I place mine, right about on the NI. So I'm going to go right directly straight below where the hopper is. So I can attach to this and then start going up to the hopper. A few more zip ties out. All right, so this one is the strain relief so that it doesn't get unplugged on accident. So leave yourself a little bit there so you can work with it if you need to. Tighten that in. Okay, then we can jump straight up to our hopper side here. So I'll throw another zip tie down. You could probably anchor it to the wires, the power wires that are there as well if you wanted. Especially, again, since I think we're well into using a lot of anchors now. But this will go straight up into that. And now I've got all of this extra stuff that we need to deal with. I'm going to just kind of get myself a little coil here. And I think that is where I'm going to put it. So for this, then, I'm going to need 2 more anchors. So one of these anchors is going to go right in line where everything is starting to spool around. So right about there. And we'll get a zip tie through the middle of my loops and just around one side here. You could probably do both sides and squeeze the whole. Do I want to just do that? Do I believe that's fine? Yeah, that's fine. Let's just take the whole bundle and put it in there. The alternative was you could do one side of the loop here and then do a second anchor for the other side of the loop. But I don't think we're going to squeeze it too tightly to where we're going to hurt these wires. So this one will kind of get it started. And then bring those wires into a cute little bundle there. All right. Let's snip these zip ties. And now we've got the signal light in. I think at this point, the only thing we have left to do is wire up some batteries. So I'm going to clip the rest of the zip ties that I missed and then get rid of all this stuff so we have room to attach a wire to the end of our battery. All right, we've got our battery and additional supplies that we're going to need. This battery, I think I got from the Rookie Kit of Parts, or the Black Tote, so the Kitbot Kit of Parts. So you should have one that looks like this, but there are a few different brands of battery that are legal, so yours may look a little different. That's fine. And then this was just loose in the bottom of that crate, but there is this little baggie of hardware that we're going to need to use. And this has the bolts and some washers and some lock washers in it. So you have to dig through the bottom of the crate to find that. If you buy a different battery, your fasteners might be a little bit different if it's a different brand, but it's going to work roughly the same. And then we have another one of these Anderson connectors. So this is the big connector that we attach to the robot side for our main power. 2 of the same connectors will plug in together. You can buy these connectors separately and try to make your own cable. I would strongly suggest that if you don't have any more of these in either your Rookie Kit of Parts or the kit of parts that you got, to buy more. So these are, it's a little hard to make this end of the cable. It's going to save you a lot of time, especially if you don't have the right tools or the right equipment to be able to do the crimps and put it together. It's going to save you a lot of time to just buy it built. And in fact, if you buy ones that also have ring terminals on the end, that's even better. Going to save you even more time. All right, but I've got the ring terminals that we used before, and we'll use the same crimper that you used. However you were able to crimp them on the robot side, we're going to do the same thing here. Okay, so first step, let's get the ring terminals crimped on. So we know it's going to be, and we can sort of twist this over if we have to, so if it's facing the wrong way, it's not a big deal. So we'll pull these insulation ends off, get a couple more of our ring terminals out here. And one of the things with these ring terminals is, one of the reasons I was talking about, like, we're kind of either going to be flat or upright, is they're a little bit too tall to be in on an angle. That corner of it kind of hits. You could go ahead and file that corner down a little bit in order to make it fit. But you know, this is the main battery connection, so I feel like I kind of want to mess with it as little as possible. All right, so we said we're going to go like this, and we're going to be bent off to the side. So I want, when the cable's flat, I want to try to crimp this connector on perpendicular. So if the housing is sitting flat, I want my connector to be up and down. Now the wires will twist, so if you don't do it, that's not, you know, a huge deal. All right, and then let's go ahead and get our crimpers on there. And remember with this, you just squeeze as much as you possibly, you just crush the heck out of it. And then I'm going to do a second crimp in the spot next to that one. Again, giving it as much as I can. All right, and we'll pull on it. It's not coming apart. That looks good. And then the red one should be facing the same way. So I'm going to get the red connector on here. Make sure you get every strand inside. And I'm going to have this one facing the same way. Maybe I'll rotate it. But still, you want it vertical. So as long as it's vertical, you're going to be OK. And then let's crimp this one down. And move over, and I'll do it a second time. All right, that seems good. Now we'll bring our battery back over. And so the red side's covered. I'll do the black side first. I can attach this on this side or on this side. It doesn't really matter. I think I like putting the tab on the side that the wire is a little bit better. Just because it kind of like, you know, I don't know, it kind of like feels more compact, but it doesn't really matter. All right, and let's go ahead and open up our baggie of hardware, and we'll dump that out and take a look at it. So we have 2 bolts in here, and in addition to the 2 bolts, we've got 2 nuts, and then we've got regular washers, and we've got these split washers. So we're going to use one set of everything on each side. Okay. So let's go ahead and start with, we'll start with the bolt going through the tab on the battery. And then I'm going to put the connector in, my ring terminal. Then we're going to do the regular washer next. And then the split washer. And then the nut. And this nut is a little sticky, so when you try to get it started by hand, it might not spin very far very easily. So just keep that in mind. And it's also pretty full with the terminal on there. There's not a lot of extra wire. So our goal is, sometimes if you hold the connector, you can get a little bit more space on that bolt. Let me try flipping it around and see if the other side will go. All right, I think I got it started now. And you definitely want to feel it going by hand first before you start tightening it, because we don't want to, we don't want to have these ones cross-threaded. And now we'll switch to the tools to tighten it. So you're going to need 2 5/16 wrenches. So I have one 5/16 wrench and one 5/16 socket, which is going to work for me. There is a Phillips head spot here, which can work, but it's hard with the Phillips head to really make it as tight as we want to make it. So I'm going to go ahead and get this so it is starting to get tight. And then I'm going to adjust the wire. I'm going to try to be sticking more or less straight flat. I definitely don't want it sticking up because it's going to hit the floor. But I don't know if it needs to stick down. If it sticks down too much, it's going to be harder for us to insulate it afterwards. So get that on, and you need to make this pretty tight. Okay, so after you're done tightening it, go ahead and see if you can get this to rotate. If you can get this to rotate at all, it's not tight enough. So that one is actually just barely, when I push down there, it just rotated a little bit. So I'm going to try to get a little bit more of a turn. It seems like my socket on the bolt head is slipping easier, so I'll try to tighten on the nut side this time and just hold the socket in place. And that was a little bit more, and that still moves a little bit, so I'm going to give it one more tug here. All right, that is about as tight as I can make it, and that is not moving anymore. All right, perfect. That's one side done. Now, well, almost done. We're going to go ahead and insulate it. Now, if you have heat shrink, it's weird because we're doing this one at an angle, but you might be able to get some heat shrink that goes over that, and you can heat it up with a heat gun or a lighter or whatever you have. That would work, but we did get the black electrical tape in the kit of parts. So this is the black wire, our negative wire, ground wire. We're going to go ahead and use the black tape to match. And it's going to be a little tricky going around the corner. So if you have to do multiple pieces of tape or you have to keep trying, the goal is just make sure everything is covered. And what I like to do is I like to start with a strip and bring it down on the inside here where it's the hardest to kind of get. And then I'll wrap one end around, trying to bring that in as tight as I can. And then I'll bring the other end back around. And then we'll work our way around the corner. And it's okay if we wrap the same place twice. We're just trying to get everything really nicely covered. And if it ends up being 2 layers, that's probably even better for us. So when I'm spiraling up here, I'm spiraling up slowly so we get plenty of coverage. And then at the end, we'll give it a snip and finish it off. Now, if you did that and you're looking down around the bottom here and you're like, oh, I still see some metal showing, or if the corner is starting to poke through, you can wrap the whole thing exactly the same again, but sometimes I'll just take like a little section of it, a little section of tape, and just try to get that bottom, right, that down on the bottom section here covered again, and sort of like wrapping that one through. And that seems to work pretty well to get everything covered. All right, so that side looks good. Let's now move over to the red side. We'll pull our safety tape off and line that up. So same pattern. We're going to do the bolt through the middle. Okay, and then we will do the flat washer. So we'll do the ring terminal, bolt, ring terminal, flat washer, split washer, and then we try to get that nut started on there. Okay, that one wasn't as hard as the first one, so that's good news. And now we start tightening. Okay, when it starts first getting tight and we can still kind of move it, I'll sort of flatten that out just a little bit so we have room underneath for our electrical tape. And then let's go ahead and keep tightening down. Oh, it will rotate sometimes when you tighten, so just be aware. The angle, again, if it's off a little bit, no big deal. Oh, this one really just wants to move. All right, that's fine. But let's try to get it nice and tight. Okay, and I can still just barely rotate that. So we're going to give it another bit of tightening. And that's got to be close. All right, I cannot move that. That's good. So this time, we're going to switch to the red electrical tape. So there are some rules when you have constant power side or supply side wires. You need to have the colors matching. So red always needs to be the positive wire. Black always needs to be the negative wire. So Even the electrical tape here should match. You should do red and black electrical tape. You could probably get by with black on both sides, but definitely don't do red on both sides. So that's something that an inspector at the event might have you change if they don't like the color that you used. All right, so let's do the same thing. Let's get down to the bottom, and we'll bring the one tab over first. And then we'll go back around. And my tape is sticking to itself. Okay, I would definitely want to get around that corner again, right? Because that sharp corner is a place where it could definitely start to break. And then loop it back under. And then we just keep spiraling. Okay, that one, the end of my tape twisted, so I'll just go back around again. Cover it up. And work our way up towards the insulation that's already there. And cover it up. That looks good. All right, let's see how this goes in the robot, right? So hopefully our wiring choices and directions were good. All right, so that's kind of weird. It's nice like if this would stay down, I think, when we go in. But then there's lots of room to put it in. And then our plug is right here. That's pretty nice. Yeah, okay. The only thing you could do, and this is very much an optional thing, is we know we kind of want the wires always to be going this way. Unfortunately, when you set this in things in order to like charge stuff, then you can't have that. So probably I would just leave it alone. I would kind of have it trained, have the wires kind of trained to bend down like that. Remember, we don't want to like yank too hard right at the seam here, but it's nice to be flat. And if you want to try to keep your battery a little bit more protected, it would be yet another zip tie anchor. I would get the bigger ones. So these ones are kind of tiny for small wiring. Unfortunately, that's all I have. But they do sell bigger ones that stick a little bit more. But it is like if we kind of bring these wires back just a little bit, so there's a little bit of strain relief back there, and we stick a zip tie anchor somewhere around the middle of the battery. And then we could add a zip tie onto those wires. Just to sort of like help keep it flat when we go to put it inside the robot. And now we'll see with that zip tie there, right, when I go to install this in the robot, first of all, I have a lot more room to fit it in. That wire's not crashing into stuff. And then I can go ahead and plug it in. That's good. And then same thing when we go out. It just helps to keep it under control. But then, because we have the zip tie anchor there, when this gets bent back up to set this down and start charging it, that force from moving this wire around is not always translated back to these bends that we put into the battery. So that's probably not a bad idea to do. But you can probably get away without it if you're careful with the battery. All right, so battery is good. Now that we have a battery ready to go and our robot is, in theory, completely wired up, I think we can do a really quick power test just to make sure everything turns on the way that we hope it does and that the whole thing is kind of wired. Well, we can't know if it's 100% wired right, but we can get a good idea of how it's doing. So let's actually go ahead and put that battery into the robot. And then I will add the strap. And I think it is fine for this strap to go across the top of the Velcro or of the battery leads. Because like I can still, right, it's not going anywhere. Right? We're trying to compress the wire, which is still just like copper, right? Like it's not anything fragile there. Go ahead and plug it in. All right, now here's the next step. We're going to go over here to the power button. And we're going to press the power button. Remember, it's the lever on the side. So we push the lever in to turn it on. And then the red button on top turns it off. So we got the lever on the side. And what I'm going to do before I turn it on, though, is I'm going to turn it on. And then I'm going to immediately go to that button on top to be ready to turn it off. If it looks like anything starts smoking or I get any bad vibes, I'm basically just going to turn it off, think about what happened, and then turn it back on again to get more information. So let's turn it on. We should see a bunch of things light up, and we should see no smoke in the robot. I'm pretty happy with that. You might get some beeps as well. You might not get those beeps yet. That is some of the, I think the motors, the cross-the-road electronics Krakens that are beeping when they turn on. This all looks good to me. Everything lit up. So now we kind of do a tour of the lights that you should see. The first one as I walk around, and most obvious here at the top of the robot, is the robot signal light is going to light up. So we got a nice glow from that. All right, and then kind of we can work our way around the modules. Every single one of your Krakens should have some flashing lights. And the light on, we'll see it on the back one maybe a little bit better. Well, this one actually is not lighting up, so that's something to check. All right, all of our CAN coder lights should be on. So I got this one over here, which is, this one's easy to see. We got that one flashing. I can see the motors flashing on the bottom. We should see Spark Maxes lighting up. There's a LED below the S on the Spark Max that's going to be blinking. We should have a voltage reading on our power distribution hub, and you should have lights on all of the channels, actually solid lights where there is no fuse or breaker, and flashing lights where there is a breaker. You should have your other Spark Max, check that. You should have your Canivore and your Pigeon should have flashing lights on them. The Robo Rio should have a power light for sure, and maybe, and the robot signal light. You might have a status light, you might have a radio light, you might have other lights, you might not on that, depending on the state of your Robo Rio, if you're reusing it or if it's brand new. And then finally, our robot radio here on this side should also have, I mean, there's a set of lights there, and you should have something lit up. It might not be the exact same as mine, again, because this might be a brand new radio. You might be reusing one. You know, I don't know. But that looks pretty good. It looks like my only thing I'm going to have to check is this one CAN coder. I'll have to check the wires on to see if those are plugged in all the way and if there's any breaks in it. But otherwise, everything is looking good. If you've got all your lights, then you are good to go. If you don't have all your lights, basically find the device that didn't light up, follow those wires through, and see if there's any missing stuff, any places where it's not plugged in. Maybe you have a fuse that you forgot to put in, or you have a breaker that you forgot to put in. Those are the most likely causes. And also make sure it's always red to red, black to black on all of our connection joints. All right, that looks pretty good for this robot. I think it is ready to go. You could jump forward to programming videos or build the bumpers next. I think we're going to try to get the bumpers built. It's always good before you drive your robot around a lot to have bumpers on the outside, because this is a little bit durable, but if you're crashing into people or walls or things, you can damage the robot, you can hurt the people. So having those bumpers, the soft edges around the outside of it, is always going to be a good thing before you go and start driving around in serious. But your programmers could start working on getting your software, getting all the devices updated for the season, and they could even start doing some of the software work and tuning stuff in. And then maybe you get the bumpers done in parallel, throw those on before you go out and do any major tests. All right, that's it for this video. We'll see you in the next one. But before we go, another special thanks to Argosy. First, Cross the Road Electronics, West Coast Products, Aramco, and Team 302, Lake Orion High School, for hosting our studio.